We're getting there. Yeah, but using the definition of derivative, right? The definition of derivative is the limits. Yeah. After this first test, we'll find derivatives using the shortcuts of derivatives, using the derivative rules. So, and if you're brand new to calculus, we're about to define what a derivative is. I haven't really used that word officially yet. So if you're wondering, what the hell is this shit about? We're going to define it right now. So again, the general process to find the slope at any point of a function is to use this format here. And in fact, here's the real general way to do it. So you make this a specific number if that's all you need and you're sure that's all you need. But you might as well go ahead and do it just for anything and then plug in any number you want to later. So how does this make this look a little different? It's not going to look too much different. What's f of x plus h? So you got to plug in x plus h in there, right?
X plus h squared.
Yeah, x plus h squared minus 2, which is?
X squared plus 2xh plus h squared minus 2.
Alright, that took you forever. Sorry. Good. So you get x squared plus 2xh plus h squared minus 2 minus, what's f of x? And here's the first mistake people make. Let me write this. I'm going to make a mistake.
X squared minus 2 parentheses.
You took my mistake away. Don't do that. That's a mistake. I appreciate that. That's the right way to do it. It should hurt you to do that. It hurt me to do that. What am I subtracting? I'm not subtracting part of f. I'm subtracting f. That's f. Shit. So parentheses and negatives, they find ways to kill us always, right? Don't let that happen. You're the human. Right? Don't let that happen. Yeah, thanks very much. All over h. But, I mean, this is not a bad idea. It's an excellent idea. Do some work on the side and then bring your answer in so you don't have all this shit happening at once. If you're not used to doing that, it's a really good idea. Now, what can I do? Here, your x squares cancel, right? Your -2 minus -2, they go away. And everything left has what in it?
H.
That's going to be guaranteed to happen unless your functions get really funky. Can you imagine trying to find if it was the tangent? Then you got to do some weird ass shit for that. But you know, we're going to deal with polynomials for the most part. So we get 2xh plus h squared over h, and of course, what happens immediately there? Is everybody with me right now? The computations involved here are nothing big. In fact, they're like math 103 level. Scheiße. But the ideas are kind of big. So the h cancels, one h cancels from each. And if I let h go to 0, I get 2x. So some of you guys know the rule. In fact, what does it look like maybe the rule is? What if it was a 3 there? What do you think might have happened?
3x squared.
3x squared. Yeah, so later we're going to prove that rule, and then we can use the rule. I'm not going to let you use the rule until we have proven it in class. Right? So that day is coming. Thank God. Right? This sucks.
Yeah.
It does. But too bad. Are you in my class? Yes. So this is not f anymore, right? What is that? That is the slope of f everywhere. So that is what we call the derivative. So the derivative, you need more letters, there, of f of x. We'll give it the symbol f prime. That's how you read that, f prime of x. So that prime means one derivative has been taken. I could take another derivative, I could take another derivative. So derivative is the calculus name for slope. There it is. That was the whole purpose of this, right? So f prime equals 2x. I like it. And why does it make sense? Does it matter what number this is?
No.
No, because the slope doesn't care where the parabola is. The slope is going to be the same no matter what the y-intercept is. If I move it up and down, the slope's not going to give a shit. Right? I like it. So that's why these constants somehow... In fact, what's the slope of a constant? 0. So any constant basically becomes 0 after you take a derivative because its slope would be 0. Kick ass. So now if I wanted to know what's the slope at 3, we get 6 again like we did earlier, right? But now I can also, somebody said 4, I'm like, Okay, good. I got 8. Screw you. You don't have to redo the whole thing. You can just do it once. So this is section 2.8. Section 2.7 says put a 3 in there. Section 2.8 says, oh yeah, but you can just put an X in there and then use whatever you want to at the end. That makes more sense to me. I gave you the practice test, right? Yeah. Everybody got a practice test? All right, so on Monday, the answer key, and by the way, Monday we have a quiz. Oh, Jeff, you suck so bad.
On what section? All chapter 2? Not the whole thing.
No. In fact, I'm not going to have epsilon delta on there. It's going to be 2.5 and 2.6, continuity and infinite limits. The limit is x goes infinity, those kind of things, right? So 2.5 and 2.6 quiz on Monday.
I went over here to page 29.
Oh shit.
Or number 29, page 70.
I didn't double check to make sure it was still right. For me it is.
That one, right?
Yeah.
So what I was
Think
thinking was for domain and range. Domain range, what do we need an equation to solve?
No. I can see what x values work. I can see what y values work. That's all I need for domain range.
So you're saying
Domain is the x values that work, and range is the y values that work.
okay, so anything with that falls within that context.
Yep, cool.
I do run phases.
Oh yeah. Cool. Thank you. Oh, cool. Thank you.
Is there going to be any good tutors in the tutoring center? Like anyone who would recommend?
To be honest, I'm out of touch.
Hard for me to like understand it from the book.
I'm actually meeting with them. I'm teaching them about epsilon.